All right, greetings everyone. Welcome to the fourth and final video for section 7.1. Just looking at another example that involves solving trigonometric equations using identities and U substitution. All right, so here we're asked to now solve cotangent of alpha equals 4 times cosine of alpha. And notice, as you see above, we're looking for answers between 0 and 2 pi. And I should note, all the examples in this video are looking for answers between 0 and 2 pi, but we could do this for, say, the first, so many positive solutions, like 3 positive solutions or 4 positive solutions or whatever we want to define. And or we could do this for all solutions. So do keep that in mind. Now, if you recall from the previous video, our general approach to a problem like this is to first try to write it in terms of a single trig function. So we want to try to do that with this one. Now, it doesn't look like there's an obvious way to do that right away because we have cotangent and cosine, and there's no direct connection between the two. But we do know we have an identity for cotangent, right? And we're going to break it down to in terms of sines and cosines, especially because there's a cosine on the other side of the equation. So in this case, we know that cotangent is equal to cosine of alpha over sine of alpha. So what we'll do then is here in our equation, make that substitution. This will become cosine of alpha over sine of alpha equals 4 times cosine of alpha. And then we probably don't want to keep that sign down there in the denominator. So we can get rid of that by multiplying by sine on both sides of the equation. All right, and when we do that, we end up with cosine of alpha equals now 4 cosine of alpha times sine of alpha. And I'll tell you, in this case, it would be really tempting to divide both sides by cosine of alpha so that the cosine of alphas all disappear and we're just left with answers in terms of sine. However, I'll tell you right now, we do not want to do that because that will actually get rid of some of our solutions. Okay, so what are we going to do instead? Well, what I'm going to do is set this equation equal to 0 by subtracting cosine of alpha from both sides of the equal sign. Okay, when I do that, on the left-hand side there, those cancel out, so we're just left with 0 equals, and we have 4 cosine of alpha sine of alpha minus cosine of alpha, which might look a little messy, but notice we have two terms here, right? This one and this one, that have something in common. And that thing they have in common is cosine. So what we can do is actually factor a cosine of alpha out of those. We'll do that, we'll end up with 4 sine of alpha minus, and we factor the cosine of alpha out of the second term, it just becomes a 1. And now we have cosine of alpha times 4 sine alpha minus 1 equals 0. We can set up two equations now. Just take each part and set it equal to 0. So say cosine of alpha equals 0. And 4 times sine of alpha minus 1 equals 0. And then cosine of alpha being equal to 0, we have to think about the places on the unit circle where that happens. And we know there are 2 of them. That happens at pi over 2 and 3 pi over 2. And then for 4 sine alpha minus 1 equals 0, we can solve that to give us sine of alpha equals 1/4. That's not on the unit circle, so we have to use our calculators to solve that. I'll put those solutions over here. So we could do inverse sine of 1/4 to get the first answer there, which gives us 0.2527. And then that's an answer in the first quadrant. Since the sign ratio is positive, we know we should also have an answer in the second quadrant. And so we can do pi minus that to get our second answer, which would be 2.8889. Okay. So end up with alpha equals pi over 2 and 3 pi over 2, as well as 0.2527 and 2.889. And there we go. Now, the last thing I'll say about this is, as I mentioned in the previous video, these types of problems, I can't just tell you do this every time. They're all a little bit different. Notice in this one, we didn't even use any U substitution. So I just have provided a couple of different types of examples here, but know that each problem might require a little different approach. But that general approach about trying to write the equation in terms of a single trig function if possible, and then using U substitution to solve, that's always going to be a pretty good approach to take. All right, that's it for now. Thank you for watching.